Okay, so now we want to talk about composition of functions. We've been talking about functions being injective, surjective, and bijective. We just want to add to that some discussion of composition of functions. So first, let's just remind ourselves of what the picture is here. So we have some set A, we have some intermediate set B, and we have some set C here at the end. We want to consider a function g from A to B and a function f from B to C, right? And so when we compose those, we're going to get a function from A to C, which we will denote f composed with g here. And in particular, we have some A, which could be sent to some g of A, which will be sent to some f of g of A under this map. Great. So that's what we want to study now in this video. And so let's just give a formal definition here. So let A, B, and C be sets. G going from A to B, and F going from B to C. Then the composition of functions is denoted F composed with G and is defined by, oh, first of all, F composed with G is a function from A to C, where F composed with G of point A in the domain is given by G of A plugged into F. Okay, great. So that's the formal definition. And we just want to play around with some sort of picture examples first, and then we'll build up some intuition here. So we have G. Maybe we're just going to go from a 3-element set to a 3-element set. And then we'll have F going from a 3-element set to a 3-element set. So that's like G here and F. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's assume that that G sends 1 to 2, and 2 to 3, and 3 to 1, and F sends 1 to 3, 3 to 1, and 2 to 2. So notice that both F and G in this case are bijections. They're 1 to 1 and on to. And now we just want to play around and figure out what their compositions are. And since there's two functions, we can compose in two different orders, so we'll do both. So in particular, we can write down what this composition is, and we can write down what this composition is, right? So again, since the domain and codomain of both functions are the same, the domain and codomain of the composition will also be the same. And so let's just set that up. Okay, so for this first one, we do G first, then F, right? So 1 gets sent to 2, and then 2 gets sent to 2. So under the composition, 1 gets sent to 2. So G first, 2 gets sent to 3, and then 3 gets sent to 1. So that means 2 gets sent to 1. Now we should expect 3 to get sent to 3 because it's a bijection, but let's just check. Under G, 3 gets sent to 1, and then under F, 1 gets sent to 3. So yes, 3 gets sent to 3. Now we do G composed with F. So F goes first. So 1 gets sent to 3, and then 3 gets sent to 1. So 1 stays put. Under F, 2 gets sent to 2, and then 2 gets sent to 3. So 2 gets sent to 3. And then under F, 3 gets sent to 1, and 1 gets sent to 2 under G. So 3 gets sent to 2. Good. Now, here we're just going to look at composition of functions and bijections, surjections, injections, so on. But in algebra, this kind of thing is studied because when we compose two functions, we can think about that as a multiplication on groups. And because the bijection, composition of bijections will be bijections, we'll actually prove that. We know that it's closed under this sort of multiplication operation, and this gives rise to the symmetric group of permutation. So this will come up again when you study abstract algebra, and it will show up other places as well. Okay, great. So that was an example where we just like played around with pictures. So now what happens if I do something more closely related to calculus? So, or, calculus. So let's say we take F, which is from the real numbers to the real numbers, and G, which is from the real numbers to the real numbers. And I'll define F of X to be X to the fourth, and we'll define G of X to be X squared plus 1. Now, this is the kind of thing you generally do in like a recalculus class. So you've probably seen this before, but I just want to bring it up in this context to remind you of that. So this is like F and G inside of F like this. And so then that means here we want to take X squared plus 1 and raise it to the fourth power, right? So I should maybe write this as like this. And then the other one is G composed with F as a function of X is like G of F of X. And now I want to take F of X and plug it into G. So that's like X to the fourth squared plus 1. And of course, I can rewrite that as X to the eighth plus 1. So that's a situation where we want to compute the compositions and figure out what the actual formulas for the functions are as well, right? Okay, so now that we've looked at the composition of functions, we want to start adding in our discussion of injective, surjective, and bijective.